Hi, welcome to the session. We are now solving the problems which are in the module number 6, which is the portfolio return and the portfolio variance. Well, if you have my workbook, you will be able to see the question number 7 in the document which is already shared. Now, let's review the question first and then we'll see how to go ahead with this. An investor wants to build a portfolio with the following 4 stocks. With the given details, find out his portfolio return and portfolio variance. The investment is spread equally over the stocks. They have given the 4 stocks for us. And if you look at the stocks list, which they have mentioned, we have Sun, Neptune, Asteroid, and Planet. All these 4 companies' information are given here with respect to the alpha, beta, and residual variance. Also, they have mentioned the market return as 11 and variance on market return as 26. Now, when I say 11 or 26, they are in terms of the percentage. It's okay. We have this information and then we have to head towards the portfolio return. I'm sure you might be aware of the calculation of the portfolio return. However, now let's work out together. I'll be mentioning here the solution now. Calculation of the portfolio return. Okay. Calculation of portfolio return. It seems to be very basic. However, we need to just understand one important thing that we don't have a probability here where we multiply the returns of a security and then we get the portfolio return, right? Here we have alpha, we have beta, and we have residual variance. Residual variance can be written as EI square, EI square. Please make a note of this, EI square. And yeah, we know that alpha and then beta can be written as like this. Now, when alpha, beta, and the residual variance are given, we need to be bit careful in terms of doing this. This is more of the application oriented. And using the formula to calculate the security return, first of all, we have a data like alpha, beta, and the residual variance, but we don't have the security return for these companies. So we have to get a security return. Now, security return, that is RI, can be obtained with the help of alpha plus beta into RM. Now, when I say RM, what does that mean? RM meaning the market return. Alpha we have, beta we have with the question. Therefore, now can we proceed in terms of calculating the portfolio return? But before that, Sun company return, that is RI for Sun. Yes, we can. We have alpha as 0.17 plus we have a beta 0.93. This is multiplied with the market return, and the market return is 11. So I'll be just writing like this here. If you simplify this, 0.17 plus 0.93 into 11, you should be able to get 10.4% for Sun. In the same way, we can proceed with the Neptune, Asteroid, and then Planet. So let's get the individual returns for these companies. For the Neptune, you can see here we have alpha 2.48 plus you have 1.37 as the beta. This is multiplied again with the 11 because RM stands for market return. And then if you simplify this, you should be getting 17.55%. 17.55%. The similar way for the asteroid, it's very simple. We have 1.47 as the alpha plus beta is 1.73. And then we are multiplying this with the market return. And if we simplify this, we should be able to get 20.5%. And lastly, for the planet, we have alpha 2.57 plus we have beta 1.17 and the market return as 11. And if you look into the alpha plus beta into RM, you should be able to get 15.44%. Now we have, in fact, the individual security returns. With this, we can calculate the expected portfolio return. This, I'm sure you all are aware of it, to calculate the expected return of a portfolio. Simply, you take the returns of individual security and then you'll be multiplying with the weights or the probability. Well, in this question, they have mentioned that an investor wants to build a portfolio with the four stocks. They have not given any details about the probability, which means that you can assume it as equal proportion an investment on all these four companies, which means that you can consider 25%, 25% on Sun, 25% on Neptune, 25% on asteroid, and 25% on planet. We know that it's sum up to 100%, or you can take 0.25 as weight for each security. Therefore, if you sum up that, you'll be getting one as the answer. Now, we are just applying the individual security returns with their weights. Let's proceed. I'll take 10.4 as the return of Sun, and this is multiplied with the weight of Sun. And now if you see here, this is related to Sun company. In the same way, now I'll have to proceed with the other securities. So we know that the formula says summation of, right? I believe you know the formula, that is summation of security return, right? The security returns, you have security returns, that is RI, and this is multiplied with the probability or the proportion. And when I say the summation, definitely you will be keep on adding the number of securities to get the portfolio return, and that is what we are doing here. The second security is 17.55, and this is multiplied with the weight of that security, that is 0.25, plus the third security, 20.5%, and this is multiplied with the weight of that particular security. And then again, the last security now, 15.44, and this is multiplied with 0.25 weights of that security. If you simplify all these things, you should be able to get 15.973% as the portfolio return. I repeat again, we worked out on the foundation of the portfolio return calculation, which goes with the summation of RI into P, which means that return of I security is multiplied with the probability of I security, and we keep on adding the number of securities, whatever we have, to arrive at the expected portfolio return. So this is how you can arrive at the calculation of a portfolio return. Now the challenge is that we will have to get the portfolio variance. Now the question is, how do we get the portfolio variance? Well, let us proceed in terms of understanding how do we proceed with the portfolio variance. Yes, when we have alpha, beta, residual variance, we know that how to proceed with the portfolio return. That is what we have just seen here, using an equation to figure out the individual security return and then proceeding to portfolio return. However, now we will have to proceed with the portfolio variance. Come on. Let me mention here calculation of portfolio variance. It seems to be very easy when you look at the question, because it is simply saying portfolio variance, but on the basis of the given data, the question is, how do I proceed with that? Since this is an application oriented, you will have to use a particular formula to go with. Come on, let us now look into the formula, that is portfolio variance, which can be solved with the help of this equation. Now, I'm just mentioning here portfolio variance. This is equal to, come on, let's take down the formula. The summation of xi and then beta I, and this is within the brackets whole square multiplied with market variance. This is 1. And this should be added to summation of xi square multiplied with ei square. I already gave an update saying that ei square is nothing but the residual variance, and we are simply applying that. Now, at the first instance, we can work on this. Let's get this summation xi beta I within the brackets square. This is multiplied with market variance. Now, how do we solve this? This is what now we will be looking into. Xi is nothing but proportion, or you can simply say weight. Right. Now, let's apply the formula on the given data. Xi happens to be 0.25, which we just discussed, because an investor wants to build a portfolio on these four securities. Therefore, 0.25 happens to be the weight. Now, what I'll do, 0.25 for the first security is multiplied with beta I. Now, let's say Sun as the first company. So I'm just writing the weight of Sun, that is 0.25, and beta of Sun company is 0.93. So I'll be writing that 0.93. Now, I will be writing plus because we have a summation, right? Since there is a summation, I'll have to proceed with 0.25. The second company that is not shown, this is multiplied with, the weights are multiplied with beta of the second company that is not shown, 1.37, plus weights of the third security that is asteroid, and that is multiplied with 1.73. 1.73 is the beta of mature, plus the last security weight, that is 0.25, is multiplied with the beta of the last company, that is planet, 1.17 into 1.17. And now, if you see, we need to apply square. And then this will be multiplied with market variance. Market variance is given as the question 26. So I'll be writing 26. Now, I'll have to simplify this. If you do the multiplication of 0.25 into 0.93, you should be able to get 0.2325 plus 0.25 into 1.37. If you do the multiplication of that, should be able to get 0.3425 plus 0.25 into 1.73, we should be able to get 0.4325 plus, and the last thing, 0.25 into 1.17, we should be able to get 0.2945. And now what we will do, we will be applying the square for this, and then you will say multiply with market variance, that is 26. Now, if you add all these things and then apply the square, right? When you add all the four values, you should be able to get 1.3. Now we are getting 1.3, then we are applying square and then multiply with 26. Now, if you multiply 1.3 to 1.3 or 1.3 square, you will be getting 1.69, and then you are multiplying that with 36. You should be able to get 43.94 for this portion. Summation inside into beta I square multiplied with market variance. Now we need to apply xi square multiplied with ei square and then make a total of it. For this, what I can do, I can just help you here. Anyway, you have ei square, you can get the xi square. Xi, we know the value of xi as 0.25, right? So which means that you will be just applying 0.25 square for all the securities. I was just mentioning here 0.25 square, and again 0.25 square. If you do the calculation, we should be able to get the values here. We need to multiply the values of those squared with the residual variance. Yes, when you multiply 0.25 into 0.25, you should be able to get say 0.25 0 6 to 0.0625, and this is the same for all the four securities, 0.0625, 0.0625. Right. And now what I'll do, as per the formula, I'll be just multiplying the xi square, that is this. Yeah, we have this xi square. This is now multiplied with ei square, and that ei square is here. So I'll be mentioning here xi square and then ei square. I'll be writing the values here so that you should be able to understand in simple words, right? Okay. If I multiply 45.15 into 0.0625, we should be able to get to 0.8219. 2.8219, sorry. 2.8219. In the similar way, 132.25 is multiplied with 0.0625, and then you should be able to get 8.2656. 2656. Now, 196.28 is multiplied with 0.0625, wherein you'll be getting 12.2675. And last, 51.98 is multiplied with 0.065, and then you get 3.2488. And now if you sum up all these things, what is the total you are getting here? When you sum up all these values, you should be able to get 26.6038. Now we can apply the formula, that is the portfolio variance. It is a simple portfolio variance is equal to the calculation of summation xi bi whole square multiplied with market variance is already here, 43.94. So I'll be just taking that 43.94 plus, if you see the formula, summation of xi square is multiplied with pi square. Pi square is nothing but the residual variance, and the total is here. I'll be taking that maybe 6.60. I can just write the rounding off instead of 3, I'll write it as 4. Now, if I sum of this, I should be getting 70.54. And now, if I want the standard deviation of a portfolio, I should be getting now, if I just apply the square root of 70.54, I should be getting 8.39 as the answer. 8.39. So this is all about the portfolio return and portfolio variance when alpha, beta, and the residual variance is found. This is bit typical. I hope you have enjoyed this video. You have understood the concept. If you have any questions, you know very well that you can always ping me, and then we can take it up and then look into the queries. Thanks for watching.